Good day everyone. I'm Yobel Jan G and my topic is all about particulate matter, PM10 concentration. And today I am going to present Geostatistics for Air Quality Mapping, Case of Baguio City, Philippines, by R.V. Ramos, A.C. Blanco from the Department of Geodetic Engineering, University of the Philippines, Diliman, Quezon City. Air quality monitoring activities in the Philippines has been undertaken by several agencies to generate significant information in formulating air pollution management and control programs. Mapping of air quality are often based on ground measurements using gravimetric measures and air potable sensors, remote sensing methods, and atmospheric dispersion models. In this study, Geographic Information Systems and geostatistical techniques are employed to evaluate coarse particulate matter PM10 concentrations observed in the central business district of Baguio City. And the objective of the study is to determine the location and distribution of the PM concentration within central business district of Baguio City. The spatial temporal variation of this pollutant concentration are to be characterized using Geographic Information Systems based geostatistical modeling. Geostatistical modeling is conducted to refine estimates of hourly PM10 concentration resulting from Gaussian baseline source dispersion model simulations. The simulation results comprise of two 20 by 20 gridded point locations of receptors with PM10 concentration values. The geostatistical modeling process involves several steps in order to obtain detailed estimates of PM10 concentrations, particularly at 5 by 5 meter spatial resolution. The process is employed through the available geostatistical analyst toolbox in ArcGIS. The specific steps undertaken in this geostatistical modeling of PM10 concentrations are illustrated in the figure below. Variograms are the primary geostatistical tool for analyzing the spatial continuity of a given attribute and can provide visualization and quantification of the dispersion and patterns of continuity or anisotropic behavior. In this study, all variogram model types are tested initially, and it was observed that 5 model types are closely related to the datasets and showed small prediction errors. These variogram model types are circular, Gaussian, exponential, spherical, and stable. The spatial interpolation involves search neighborhood parameterization, assessment of prediction errors, and comparison of geostatistical models. The search mode is represented by a circle on an ellipse that can be divided into sectors, from which an equal number of points are selected to avoid bias in a particular direction. Results and discussion. Sample histograms linked with the spatial data are illustrated in this figure. The histogram shows that PM10 concentrations are not evenly distributed within the extent of the model. The histograms for all the simulations show that values are skewed to the left, which indicates that most of the measurements are within or below the mean concentration. The normal QQ plots, a sample of which is given in this figure for daytime hours 6 a.m. to 7 a.m., show that the pollutant concentrations do not follow a normal curve and are consistent with the information presented by the histograms. Prediction errors are assessed in each test and sample results using one dataset. Nighttime hour 12 midnight to 1 a.m. are provided in the table. The results show that the exponential variogram model produces the least errors of RMSE, an average standardized error, and the highest value closest to 1 for RMS standardized error. Dispersion modeling results show general patterns of spatial variations of the pollutant concentrations for daytime 6 a.m. to 6 p.m. and nighttime 6 p.m. to 6 a.m. The pollutant concentrations are evident within the 40 meters from the roads and are shown in the sample datasets in this figure. From the geostatistical modeling results, spatial variability of the PM10 concentrations is more evident on some portions of CBD such as surrounding areas in the north and northeast side containing road segments: Bukwan Road, Magsaysay Avenue, Session Road, General Luna Avenue, and Harrison Road.